Okay, number 19, nice short one. A lift moves upwards from the ground floor to the 10th floor of the building. The velocity time graph for the lift is shown. Calculate the magnitude of the maximum acceleration of the lift. So remember that for a velocity time graph, the acceleration is the gradient of the graph. Acceleration equals gradient. And you can see we've got two gradients. We've got a gradient there, we've got a gradient here. This one looks steeper to me, so this is the biggest, this is the maximum acceleration. So we're going to calculate a acceleration of this line. It's got a bit of a curve on it, but most of it is a straight line. But what I am going to do is I'm going to draw the tangent at that point, and I'm going to get the change in the velocity is so that is the change in the velocity over the change in time. So the gradient is 3.2, I think, 3.2 minus 0 over, oops, it's in the middle of this, so 5, so that's 7.5, 5, 6, 7, so it's actually about 5 point, so it's actually 5.7 or something, isn't it? 5.7 minus, so that's 2.5, 2.5. So I've got 3.2 over that. 3.2 divided by 5.7 minus 2.5. 1. An acceleration of 1. Exactly. Okay, maximum acceleration. Sketch the corresponding acceleration time graph on the axis below. So initially here we've got no motion, but at about 2 seconds we start an acceleration, and then it is a constant acceleration until 6 seconds. So for this bit here we've got a constant acceleration pretty much. Maybe you can put a little bit of a slope in there, but not that much. Most of it reaches the maximum acceleration pretty quickly at 1.0 meters per second squared, and then it travels here at a constant speed and then it slows down. So here the velocity is negative. The gradient is negative, so the acceleration is negative. Starts at 15 and finishes at about 19.5 there. So again, you can put in a bit of a, we also want to think about the magnitude. Well, actually, I'm looking at it again, and I think maybe the magnitude is the same almost. So I'm going to go with -1 as well. So somewhere down here. Again, it gets to that speed pretty quickly. So that's my acceleration time graph for this motion. It looks like that. Okay, thank you.